Hey everyone, ever stop to think about what a computer is actually thinking? It's not English or Spanish or even emoji. Nope, it's a secret, super simple code. Okay, let's dive into this.
So, this secret code, it's made of just two numbers. The first one is 0. That's it, just 0. And the second number is 1, and that's the entire language. Seriously, just zeros and ones. It might seem too simple, but this is the foundation for, well, everything digital.
Every single picture you take, every song you listen to, and yep, every secret password you type is really just a huge long sequence of these ones and zeros.
This language has a name. It's called binary, and it's the absolute key to cybersecurity. I mean, to protect our digital world, we first have to understand the language it's built on, right? But here's the really cool part. Computers don't actually see 1 and 0. They think in terms of on and off. A 1 means electricity is flowing through a tiny switch, and a 0 means it's not. Everything your computer does is just the result of billions of these tiny switches flicking on and off at incredible speeds.
You know, we usually count in what's called base 10, probably because we have 10 fingers. But computers only have those 2 fingers, on and off. So let's learn how to count like they do, using just one hand. And yes, you can actually count all the way to 31. No joke.
Okay, you ready? Put one hand out. Each finger is going to represent a number. Your pinky is 1, your ring finger is double that, so it's 2, your middle finger is 4, your pointer is 8, and your thumb is 16. If a finger is up, it's a 1, and we add its number. If it's down, it's a 0, and we just ignore it. Simple.
Ready for a little challenge? Try to make the number 21. Which fingers would you need to hold up? Think about those numbers we just assigned. So, did you get it? You need your thumb, which is 16, your middle finger, which is 4, and your pinky, which is 1. Add them together, 16 plus 4 plus 1 equals 21. This is a perfect example of how any number can be represented with just a simple combo of on or off states.
Okay, so that's a cool party trick, but how does it connect to cybersecurity? Well, let's see how this simple on and off system is the absolute key to protecting your data.
So here's the deal. Since everything is stored as ones and zeros, hackers can try to manipulate that code directly. They know the language the computer speaks, and they can try to trick it by feeding it the wrong binary sequences.
A classic attack that does this is called a buffer overflow. Imagine your computer's memory is a bucket. A hacker can try to pour way too much binary data into it, making it overflow and spill out other secrets stored nearby, like your password. By understanding binary, cybersecurity experts can build stronger digital buckets that won't overflow.
All right, let's shift gears and talk about the internet. Binary is absolutely essential for how every single device connects and talks to each other online. Every device connected to the internet, your phone, your gaming console, you name it, has a unique address called an IP address. It's just like your home address, but for the digital world. You've probably seen one before. It's those 4 numbers separated by dots. Each of those 4 numbers is called an octet. Why? Well, oct means 8, and each one is represented by a group of 8 bits. That's 8 ones and zeros. So your whole IP address is actually just 4 groups of 8 bits.
Hey, remember our hand counting? Well, if you had 8 fingers instead of 5, you could count all the way up to 255. And that's exactly why 255 is the highest number you'll ever see in any one part of an IP address. It's the maximum value you can make with 8 bits.
So let's take the first number from our example IP address, 192. How does a computer see that number in binary? It's really simple math. The first bit in an octet is worth 128, and the second is worth 64. To make 192, you just need to turn those 2 bits on. And 128 plus 64 gives you exactly 192.
And there you have it. The binary for 192 is 11000000. Understanding this is how network security experts can filter traffic and block connections from attackers. They're literally looking at the binary addresses to keep networks safe.
Okay, here's one of the coolest uses of binary in cybersecurity, and that's encryption. This is how we turn a secret message into gibberish that only the right person can read.
We can do this with a simple tool called XOR, which stands for exclusive OR. Think of it like a digital lock. You use a secret key, which is just another string of ones and zeros, to scramble your data.
The rule is incredibly simple. When you compare your message bit and your key bit, if the 2 numbers are the same, the result is 0.
If they're different, the result is 1. That's the whole rulebook. Let's see this in action. We take our message, 1010, and use a secret key, 0110, to lock it. Following the XOR rule, the output is 1100, which is completely scrambled. But here's the magic. To unlock it, you just apply the exact same key a second time, and you get your original message back, perfectly restored. This simple binary math is at the heart of many secure apps you use every day.
So, as you can see, binary isn't just math homework. It's the foundational language of our entire digital world. Understanding these simple ones and zeros gives you a kind of superpower. You now have a glimpse into how to build things, and more importantly, how to protect them. You've just learned the secret code. The only question is, what will you do with it?